our lesson today is how to solve question 6 in Haikal for math for grade 12 advanced. As you see here, the question: learn the notation of an inflection point and find one. The question here: find the inflection point and determine where is the function concave up and where is the function concave down. Okay, this is the question. F of x equals sine x minus cosine x. To find the inflection point, you should derivative twice. Then make the second derivative equal 0 and see where is the function changing from concave up to concave down to determine the inflection point. This is the strategy that we fluid to get the inflection point and determine where the function is concave up, where the function is concave down. Step 1. Step 1 here, as you see, find the first derivative of prime f of x. What the derivative of sine, cosine x? What the derivative of cosine? Negative, negative, sine x. Okay, that means cosine x plus sine x. This is the second derivative, the first derivative. Step 2, find the second derivative, f prime of x equals, okay, the second derivative of the derivative cosine, negative sine x plus cosine x. Okay, make this equal 0 to find and determine the inflection point. That means this is go there, change the sign. That means cosine x equals sine x. How to solve this equation? Which equation, which angle cosine of it equal the sine? This is means x equals pi over 4. Okay, pi over 4. This is the answer. Yes, pi over 4 cosine equals sine. Also plus 2 pi k. Yes, 2 pi k, where is k here equals negative and positive, yani putting to, yes, integer number. Or maybe some students, they didn't understand what I mean this k. Maybe k equals negative 2, negative 1, 0, 1, 2. That's mean. Okay, that's it. Okay. Maybe some students they didn't understand this. I will explain in detail about this. This is the x to show you how to find. This is cosine axis. This is sine. Yes, this is sine axis. Okay. This is the angle. This is the angle pi over 4. The cosine equals the sine. Also, this is angle. The cosine equals the sine. Plus, yes. Maybe I think here, maybe I think, as you see, you can use calculator to find this. Here also, this is the angle pi over 4, pi over 4 plus pi. The answer is 5 over 4 pi. This is the angle, I think, 5 pi over 4. To check this is maybe, I think, cosine 5 pi over 4. What the answer? negative radical 2 over 2. What about the sign? The sign, the same. That's mean we don't need here to write 2, but plus pi, yes. This is pi k, okay? This is the answer. Okay, we have here many inflection point. If the question here not determine the interval, maybe I can here from determine the interval from what? The question maybe becomes the x, the interval from 0 to 2 pi. Okay, then the reflection point here we can write here. This is the first x equals pi over 4 for k equals 0. For k equals 1, that means x equals pi over 4 plus pi. This is equals 5 pi over 4. Okay? For k equals 2, this is equals pi over 4 plus 2 pi. That's given what? Given 9 pi over 4. This is not belong to the interval from 0 to 2 pi. Okay? We have here two inflection points. X equals pi over 4 equals 5 pi over 4. Maybe to check this, we can determine this is, I think, the table. Okay, recognize the table x from 0 to pi to 2 pi. Okay, here pi over 4, here 5 pi over 4. This is f double prime of x, to check where is the function concave up, where is the function concave down. Maybe some students, this is 45 degrees, but this I think 225 degrees. Okay, maybe here we can select any checkpoint to check the sign of the second derivative. Maybe pi over 6, 30. Okay, pi over 6, 30 degrees. Or here between them by 180. This is also here maybe 3 pi over 2. This is 270 degrees. Okay, to check we can use calculator. This is easy now. What the equation of the second derivative? Negative sine x plus cosine x. Okay, right. Negative sine x plus cosine x. Then be careful to change your calculator to radian or degree. If substituted by degree, the answer okay. If substituted by radian, if we should by radian here, mode radian for calc pi over 6. Calc pi over 6. What is the answer? Positive or negative? Positive here. Okay, calc pi, as you see, what the answer? Negative here. Also, here, this is 0, this is here also 0. Okay. Calc 3 pi over 2 The answer is positive. Okay, this is concave up, this is concave down, this is concave up. That's it. Easy. Okay? It's easy to solve this equation. Now here, what about this function? How to find the derivative for in first time? Do you remember? Yes. Derivative the angle, then 1 plus the square the angle. Yes, excellent. Our angle square. This is step 1 here, as you see. F prime of x equals, what is the angle? X squared. What is the derivative then? 2x 1 plus x squared. Yes, right. This is equals 2x 1 plus x to power 4. The second derivative here, f double prime of x, you can use the quotient rule. Yes, quotient rule here, as you see. Excellent. What the derivative of 2x? 2 times 1 plus x to power 4 minus 2x times 4x to power 3 over plus 1x to power 4 squared. This is the second derivative. Okay, make the second derivative equal 0 because the denominator isn't equal 0 because this is 1 plus x to power 4 to power 2 is positive, always positive, but the numerator may be equal 0. Let's start here, simplify this fraction. This is, yes, maybe this is 2 plus 2x to power 4 minus 8 because x to power 4. Okay, over 1 plus x to power 4 squared. Okay, this is, I think, equals 2 minus 6x to power 4 over 1 plus x to power 4 all to power 2. Make this equal 0. That means the numerator equals 0 here. This is -2 negative 6x to power 4 equals 0. That means 6x to power 4 equals 2. X to power 4 divided both sides by 6. 2 over 6. This is equals 1 over 3. Then we can find x equals, okay, the radical for 1 over 3. This is, maybe you can find this. Okay. This is the point, yes. This is equals, I think, 1 to 1 over radical 3. This is the answer, x. Maybe positive or negative. Positive or negative? Yes, maybe positive or negative. Okay, that's it. Good. Now how to recognize the table here, as you see. But the question, what the domain of this equation? X from where to where? This is, look at the general equation here. Be careful. This is angle for the tan. No problem. Yes. Do you remember where is the tan? Maybe here. We hear restricted function. This one from negative pi over 2 to negative 2 pi over 2. Maybe here x. We don't go from negative pi over 2 to pi over 2. Okay. This is the angle. Maybe from negative 1 to 1. Keep silence there. Okay. Yes. Okay, go down. I think here restriction from -1 to 1, I think from -1 to 1. Yes. Here x from -1 to 1. Here -1 over of 1 of 3, and here 1 of radical 3. This is the second derivative. Here 0, also here 0. We can checkpoint here between them, and checkpoint here and checkpoint here to study the sign of the second derivative. What the second derivative equation here, as you see in the, okay, let's start here. This is fraction. Okay, 2 minus 6x to power 4 over 1 plus x to power, x to power 4. Okay, close the bracket, squared. Okay, now we can calc in the table here to check where is the function concave up, where is the function concave down. This is calc. Which one here? I think maybe I can use another calculator. More calculator, yes. Here I think, wait, -1 divided, yes, this is 4 here, for 3, this is equals -0.75. Okay, maybe we can checkpoint -0.75. Maybe here is -0.8. Okay, here between them 0, here 0.8. This is the checkpoint I can use. Okay, now we can calc. Okay, -0.8. Sorry, 0.8. What the answer? Negative. Yes, this is concave down. Calc. Yes, calc 0. What the answer? 2 positive. Concave up. Also here, calc 0.8. What the answer? Negative. Concave down. This is the question. Not easy. Should be careful about this, because this is inverse sine, inverse tan, inverse cosine restricted function. هاي دوال بنسميها دوال مقيدة بدومين معين. Okay, be careful about this. Okay, thank you for watching video. We'll see you inshallah in the next video.